While we're talking about balanced trees and ordered sets and ordered maps, I wanted to take a minute and talk about the red-black tree and in particular implementations that exist in Java, but just very briefly. So first off, I just want to look at the Wikipedia definition of the red-black tree to just give you some intuition about what it is. So it's also a kind of self-balancing tree. You'll notice time complexities look very, very comparable to what we've already seen with the AVL tree, basically log n. Okay, it's called the red-black tree because the notation that was originally used for it colored nodes either black or red, and it establishes a set of rules that are kind of comparable to the balancing rules that we have for AVL trees. The rules basically kind of coerce the shape of the tree into maintaining a logarithmic logarithmic height in relation to the number of nodes. So the basic rules are about nodes being colored. They're either red or black. The root must be black. All leaves, in this case the leaves are empty, are black. And then everything else is kind of about the paths that you traverse and the ordering and number of nodes along a particular path. If a node is red, then both of its children are black. Every path from a given node to the empty node at the bottom of the tree goes through the same number of black nodes. So anyway, enforcing these rules is a little bit more complicated than the rules for the AVL tree, just because they're a little bit harder to implement, but it results in a tree that is very comparable in many ways to the AVL tree. Okay, so part of the reason I mention this is because Java provides existing implementations of trees, the tree set and the tree map. So I'm going to take a quick look at those. So the tree set is a set. It has set operations. So java.util.treeset. And notice that it implements a navigable set interface. We'll look at that in just a second. So as a set, it has operations to allow us to add a new element, to see if the set already contains a particular element. And then as part of being a navigable set, we can get things in an ascending or descending order. I'm sorry, a descending order here. And ascending's handled by the iterable. So navigable sets are things that are iterable and basically allow us to kind of go from across the elements in order based on their natural ordering. Okay, so that's the tree set. There's also a comparable notion of a tree map. Here the keys map to a particular value, so that when you create one of these, you specify both the key type and the value type, and then it'll have the map sorts of operations like get and put, but it also allows us to traverse the map in ascending or descending order. So we can actually go through things in order by keys. Okay. So in actual practice, there are already existing trees that exist for both set operations and map operations in Java. If you need the kind of benefits of the set, being able to add things to a collection, determine if they're in the collection relatively easily. If you need to ensure that you always have at least logarithmic time and never have the occasional expensive operations that you experience with a hash map, or you need to occasionally traverse through things in order based on keys, the existing tree map and tree set are probably a good choice.